Tonight's speaker is an astrophysicist, writer and communicator with a long-held affinity with the night sky. Our speaker has and does work for major leading astronomy magazines, having been co-editor for the Young Astronomer section of the Society for Popular Astronomy, and is currently news editor of the BBC Sky at Night magazine, writing and delivering many articles from Apollo 13 to radio astronomy podcasts. Tonight's speaker delivers many well-received lectures to astronomical societies and has recently had a book released with excellent reviews entitled Robots in Space, A Complete History of Landers and Rovers. That's one small step for man, one giant leap for mankind. We're all familiar with these words, but to make Apollo happen, it took the Ranger, Surveyor, and Lunar Orbiter robotic spacecraft to pave the way for the human lunar landings. So here for you tonight, making a pinpoint soft landing at your observatory and your home, please welcome Dr. Elizabeth Pearson.
Hello everyone. Right, now give me an awkward moment whilst I just share my screen. And okay, whoops. All right, now can you all see that delightful slide there? Good. Okay, excellent. So yes, as I got introduced, I am Ezzy Pearson. I'm the news editor of Sky at Night magazine, which basically means I am a professional space enthusiast. I get paid to be excited about space, which is a very good job if you can get it. And over my 15 years of studying and learning about astronomy and the night sky, one area has always really stood out to me, and that's the planets, studying our own planets, distant ones, the worlds that surround us. Specifically, I like the missions that go up and actually touch another world. I just think there's something really romantic about that, something really exciting about the fact that, you know, us little glorified monkeys over here on Earth managed to actually travel out beyond the sphere of Earth and go out and touch another world. And when it comes to sort of the progression of how we go about doing that, there are basically 4 stages to how you go out and explore the world. So the simplest missions, often the first one when we're coming to a new body, is something called impact missions. As they sound, this is literally where you just go up to something and smash into it. The image here is from the Deep Impact mission, which went into a comet. Slightly more complex is a static lander. So this is where you actually do a soft landing on the surface of another world. And these are slightly more complex, but still relatively, they're quite limited in what you can do. You can only look at the area around where you land. So then you step up to something slightly more complicated, go up to mobile missions that can move around and still look, but still robotic missions. And then finally, you have the biggest, most complex, and more importantly, most expensive type of missions, which is human missions. In fact, we've only ever done 6 of those to the moon. Well, 7 if you count Apollo 13, but they're very expensive. So for this talk, I'm going to focus in on that 3rd section, the mobile landers, the ones that can rove around all over the place. And these get a lot of PR because they're rover. I mean, look at that rover. It's very charismatic. It's charming. It's cute. But also they are very good at what they do because they offer a really good balance between safety and being interesting. So here we see on the left is Gale Crater, where the Curiosity rover set down back in 2012. And the black circles are where it actually landed. It's a nice, flat, safe area. Nothing here is going to hurt your rover when you're trying to land. However, it's also quite boring. There's not much interesting going on. It's just a big flat sand pit. Then on the right, this is where Curiosity is exploring now, going up the mountain, Mount Sharp. And it's really interesting. Look, you can see all of these different rock layers and different strategic going on. There's lots of interesting things for a rover to go and look at. However, it's very spiky, it's very dangerous, and it's not a place that you want to try and actually land on. So that's what makes rovers really good. You can land somewhere nice and safe and secure and boring, and then travel to the interesting thing without risking a human life, and most importantly, not having to bring them back, which is the bit where stuff starts getting really expensive. So they're bringing them back. So I'm getting ahead of myself a bit here. This is Mars. Where rovers actually started was over on the moon. So let's take a trip back in time. It's the 1970s. The space race between the Soviets and the US is pretty much over, and the Americans have won. They've landed on the moon, they've landed, they're Apollo astronauts. But the Soviets aren't quite willing to go out without a fight. They know at this point, the Soviet Union knows that they are never going to be able to land a human with their current state of technology. They've tried, they've looked into it, it's just not going to work. So instead, what the Soviets quite cleverly decide to do was try and change the conversation. So rather than being who is going to put the first person onto the surface of the moon, the Soviets said, well, we are going to show that we can do everything that Apollo astronauts can do with robots. And so the first half of this was to land a sample return mission, which they tried to do at the same time as Apollo 11 with Luna 15, but unfortunately that failed. And so Luna 16 instead returned a sample a few months later. But the other thing they wanted to do was send their own version of a lunar walker, or in Russian, a lunar cod, which in this case was a rover. And this was the very first planetary rover to get sent out and go onto the surface of the moon. And it was basically our first, humanity's first exploration about what actually do you need to build a rover to go and explore another world. And it had all of the basic elements that you need. It had power. So in this case, that kind of lid, it's closed at the moment, but when it was on the moon, it would open up and there was a big solar panel on that moon that would provide power to keep the lunar cod going. It had its brains. There's something called a warm electronics box, which is basically you get all of the bits and pieces that you need, because the easiest way to make electronics work in the moon is to create a box that basically mimics Earth. And then you don't need to worry about how do you get a microchip to work in vacuum at minus whatever it is degrees Celsius. You just put them all in a box, keep them nice and toasty. And so that was buried inside of this big kettle drum. Next, you need a way to move. In the case of Lunacod, it was these 8 wheels. Each one of these wheels moved independently. They could be ejected off in case one of them got stuck or wasn't working properly and causing problems. And that was the way that this one got around. You also need to have a way to look around. You need to have some eyes, which in the case of this, you can see those 2 black dots on the front. Those are 2 cameras that could look out and survey the surface of the moon. But there's also not much point in going all of this way, looking around, being able to do all these things, if you then can't send those pictures home or tell the rover what to do. So that's why you have this big, like the yellow thing that looks like a drill and the big sort of laser gun looking appendage. What those actually are 2 antennae that could communicate with Earth. And so those are kind of like the 5 basic things that you need on any moving device if you're going to send them to the surface of another planet. By the way, this was a real life, would have been Lunacod 3. It's now a museum piece. And this thing is absolutely massive. It was taller than me when I saw it in the Science Museum back in a couple of years ago. So these things were huge. It's 1.5 meters tall, I think. And then the antennas on top. But it's not much good if it's just, you know, sitting on the surface of Earth. You've got to get it to the moon first. So how do you do that? Landing mechanisms are quite complicated, very intensive and require lots of moving parts. So rather than trying to make a landing device on the rover, you put the rover on a landing device. So in this case, it's this nice platform. Get to the surface of the moon, 2 ramps unfold, and the rover can just go out onto the surface. And there's always 2 ramps. In case one way is very rocky and blocked, you can always go out the other. Always want to have redundancy when it comes to space missions. So the first mission that got sent out was Lunar Cod 1. It launched on the 10th of November 1970, landed not long afterwards. And this mission was, when it first got to the surface, there was a little bit of trouble getting it to move around. So this picture that you see here, this is actually the picture that was being sent back from Lunar Cod 1. As you can see, it's very low resolution. It's quite difficult to see what's going on. You can basically, there's no real sense of depth. There's black and there's white. And this was very difficult to drive by because Lunar Cod 1 was actually operated from Earth. So there was 2 teams of 5 drivers who would operate alternating between the 2 of them throughout the lunar day, and then at the lunar night they'd catch up on all the sleep that they'd lost. But they were trying to drive from this picture that was also quite low, so it was quite hard to see what was going on. And they really struggled with it at first. And there was actually quite a few stories about, you know, the military bigwigs coming into the driving room and being like, oh, you need to watch out for that rock. Oh my God, you're going to fall into that pit. And, you know, literally almost giving the drivers heart attacks. And then eventually Gregory Babakin, who was the leader of the group at the time, just kicked them all out eventually and let the drivers get on with their job. And they did. They learned to drive around the surface very, very well. Unfortunately, a little bit too well. And in Pravda, which was the Soviet paper of the time, the government paper, they kind of had a running tally of how far Lunar Cod 1 had gone across the surface. And a lot of people in charge got very obsessed with that number, making it the biggest number that they possibly could. And then all of the scientists were coming in saying, but we're a science mission. Can we go have a look at that rock over there? Only to be told, no, you can't look at that rock. That rock is dangerous. You might hurt my rover. You're not allowed. And so they didn't, but in time, the scientists got their way. They were finally allowed to, you know, like, we're allowed to go and look at this thing as well, don't worry. And so they did manage to get to do their science as well as traveling across the surface. The mission lasted about 10 lunar days before a sudden pressure drop happened in that warm electronics box. It got exposed to the vacuum and Lunar Cod just didn't wake up one day. 10 lunar days, obviously, being one lunar day is a month of the one whole phase of the moon. But Lunar Cod 1 was a huge success. They learned a lot from the mission, which they put into practice on Lunar Cod 2, which went up 3 years later. And in this one, they put in much better cameras, much higher resolution, much more frequent images coming back. So on Lunar Cod 1, there was only an image being sent back once every 30 seconds. So can you imagine trying to operate something from that low resolution with a picture that appears at once every 30 seconds? Lunar Cod 2, it was much, much higher frame rate. They got a whole 1 frame per second to operate by. But as you can see, picture much better. They could explore much more of the Earth's surface, moon surface. And in fact, they did, despite the fact that Lunar Cod 2 only lasted 4 lunar days as opposed to 10, it went 39 kilometers across the surface of the moon. That's the longest that anything's managed to go for a long time, until I think opportunity overtook it. And where did it go? Well, it went along here. So it started up on the top left corner, came down towards the mountains. So this is one of those kind of like magic eye things. At the bottom, those are mountains coming out of the screen, not canyons going in. So it drove along those mountains, had a nice look, and then came along to this rill, this canyon on the right-hand side, and drove along the side of that. And unfortunately, on the 4th lunar day, at some point, the rover brushed up against, it got a little bit too close to something interesting. And dust fell onto the solar panel. When it closed up for the night, that dust fell onto the radiator and cooked Lunar Cod 2, and it didn't wake up. And that was how that mission finally ended. But it did get a nice good look across a huge expanse of the moon. And what these two rovers did was something that can't be done in a lab, because bringing samples back to Earth lets you look at their composition and stuff like that in incredible detail. But what you can't do, and what you can only do on the moon, is look at how that soil, that lunar regolith as it's called, acts in a vacuum when it's being under those sorts of conditions. And that's what the Lunar Cod rovers did. They poked and they prodded and they really looked at what was going on the surface of the moon. And in fact, there's a lot of that the information that they sent back that is currently being used by people who are planning to go to the moon today and sending rovers. Because it turns out lunar dust is horrible. It gets in all your gears, and it's just really not terribly pleasant if you're trying to drive around in it. It's also apparently very chafing if you get it in your underwear, according to the Apollo astronauts. So apart from, you know, horrible lunar dust and it getting in your underwear, unfortunately the Lunar Cod rovers were a little bit overshadowed by Apollo. NASA pretty much just did a brilliant PR job when it came to the moon. And no matter what the Soviets did, even though they did a lot of robotic work that was absolutely excellent, it's kind of been forgotten because Apollo just overshadowed everything. But unfortunately, what Apollo didn't do a very good job of was keeping interest in the moon. And by the end of Apollo 17, the moon had kind of been pronounced as boring. It was this dead, lifeless world. We've been there, we've seen it, and people didn't go back for a long time. And that's changing now, but we'll get onto that in a minute. So they built Lunar Cod 3, the Soviets, but it never got sent. It became a museum piece. It's been all around the world. In fact, they sold Lunar Cod 2 to Richard Garriott, who was a games developer. Despite apparently delivery was not included in that sale. It was very clearly stated, unfortunately, so he will have to go back and get that himself. But the Soviets, rather than continuing to explore the moon, they actually went and pursued their other two, the areas that they were actually quite passionate about before they got dragged into this kind of space race for the moon. And that was exploring the planets. They had enormous success over at Venus, which I talk about more in the book, but I won't here. But unfortunately, it's not their successes at Venus that get remembered. It's their failures at Mars. And the Soviets tried to go to Mars. I think the count tally is 18 times. And every single time they failed. Sometimes they had a little bit of success, but no mission that the Soviets mounted or the Russians mounted to Mars was ever completely successful. Instead, for the last 40 odd years, Mars has been until quite recently, the purview of NASA and the US. But what's so exciting about Mars? Why do people like Mars? Well, there's many reasons Mars is interesting, but the predominant one that gets all of the press is its potential for being habitable and even inhabited. So there is always been dreams that maybe there was life on Mars. Just look at, the history of sci-fi. There's so many books that were written in the past about maybe there is life on Mars. And then as we learned more about it, this has been the big question. Was there ever life on Mars? Could there be life on Mars? Could we even go and visit and live on Mars? And the only way you're ever going to answer those sorts of questions is really if you can bring a bit of Mars back. So in the 1990s, NASA was looking at something called the Mars Rover Sample Return mission, which was basically a mission to send a rover to the surface of Mars to scoop up some samples, chuck them in a rocket, and then send them back to Earth. And they did a lot of research into this and came up with lots of plans and ideas and had some really, really great thought. Unfortunately, this was overshadowed by the price tag. The group that was working on this worked out it was going to cost around 12 to 16 billion dollars to mount a mission to bring back a sample from Mars. And that was 1990s billions, not today's billions. So it was just way too expensive for NASA. You know, they were talking moonshot money, like probably actually even more than the Apollo missions in the end. So instead, NASA looked at something cheaper. And what they came up with was something called the Mars Environmental Survey, or MESA. And originally, this was going to be 16 stations pinned all over Mars. Each station would cost a few $100 million, which when you're talking space money is a pittance, it's nothing. So even though the entire project would cost several billion, each mission would only cost a few $100 million. So if one failed, it was annoying, but it wasn't catastrophic, like if a big rover failed. But they decided not to jump in with all 16 feet first. Instead, NASA decided they were going to create a test for this landing station called Pathfinder MESA. And as they were designing this, one of the instruments that they wanted to put on board was something called an APXS, which stands for an alpha proton X-ray spectrometer. And basically what that is, it's an instrument that uses alpha particles and X-rays to look at rocks and the surface and work out what elements are in there, what its composition is. And it's a very useful instrument that is on pretty much anything that's going to another planet and looking at rocks. But if you put it on a static lander, you can put it on an arm, but it's not going to do much good. You know, they did that with the Viking landers 20 years before. They wanted to do something new. They wanted to do something different. So what they said was, hey, why don't we put it on a rover? And it took some convincing because of that work that they'd previously done to convince people that it didn't have to cost billions of dollars to put a rover on Mars. You could do it for probably about 25 million. And that's what they did. That 25 million came from a rather creative bit of budgeting, which meant that rather than being viewed as a scientific instrument, the rover, which would go on to be called Sojourner, was actually funded as a tech demonstration. So it wasn't seen as a scientific instrument. It was seen as a way to explore and look at how we could put rovers on Mars. And that came up, this is the eventual what they came up with. So as you can see, there is a lot of similarities to the Lunokhod rover. It's got its warm electronics box, which has all of its brains in, also has that alpha proton spectrometer over on the end. It's got its wheels. So in this case, those wheels are something called a rocker boogie system. And this was really one of the big revelations about how to get a rover around the surface of a planet. Pretty much, and in fact, yeah, every NASA rover afterwards has used this system, and a lot of people have borrowed it off them as well. And what this was it was a U-shaped bar, which linked your first two wheels, that was then linked by another U-shaped bar to the back wheel. And what this meant is that with the three wheels on one side could move up and down independently, navigating all of the various lumps and bumps and divots on the surface of Mars, and could deal with a pretty rough terrain. And so, which is good because Mars is a not very flat planet. There's a lot of stuff going on, and a lot of that stuff is very interesting, so you want to get in there. The other thing that was a big difference was how it communicated with Earth. Mars is, the moon was only 385,000 kilometers away from Earth. That's a relatively short distance, enough that a radio on the surface of Mars can communicate back with Earth. Mars, at its closest, is around about 38 million miles away. I think the closest it ever gets is 35 million miles away. So that's a factor of 100 difference. Radio signals tend to fall off of 1 over r squared. So that's, 10,000 times stronger signal you need to be able to communicate with Earth. And that was way more than the tiny solar panel on top of Sojourner could cope with, because Sojourner was tiny. It was only about a meter across. I usually say it's about the size of a skateboard, 2 skateboards next to each other. And that's not a very big solar panel. It can't communicate over 35 million miles. It's just not going to happen. More often, more than that. So instead, what it did was it had a shortwave communication that would communicate with the Pathfinder lander. Then the Pathfinder lander would communicate back to Earth. And this kind of relay of signals back to Earth has been a major factor in a lot of rovers and landers since. Finally, it could have a much more sophisticated brain. Sojourner, this was the 1990s, electronics and microchips were really beginning to take off. So on the moon, you could communicate in real time. There's only about 2 seconds delay between Earth and the moon if you're trying to have a conversation, which is annoying, but dealable. On Mars, there's a minimum of 8 minutes to get there and back. You can't operate a rover in real time. The only way to operate it is to upload a bunch of instructions and then have it navigate its way. It was also advanced enough that it could have a little bit of AI and be able to tell, like, oh, I'm about to fall over on this big rock. I'm going to stop now. So beginning to get the signs of this intelligent computer-controlled rover. And so this really helped us begin to design, or NASA really helped us to begin to design what a rover on Mars was going to be. So the mission eventually launched on the 4th of December, 1996. By this point, unfortunately, the MESO Pathfinder had just become Pathfinder. That big 16 probe mission had been canned. It was just deemed too expensive, and NASA wandered off and got interested in something else, as so often happens. And it landed on 4th of July, Independence Day, 1997. And it landed, so the Pathfinder station acted as the landing platform, but Mars is quite tricky to land on. It's got the worst of all worlds. It's got this it's got a very thin atmosphere. And what that means is it's too much that you can't just ignore it like you could on the moon, but there's not enough of it to be able to use parachutes to slow down like you can on Venus. So instead, you have to use a combination of aerobraking, where you use the atmosphere to slow down, parachutes, which again, slow down, but if you're going too fast, they'll tear to shreds, so you need to use the aerobraking first. But then you always need another method to try and bleed away that last little bit of velocity. In a Pathfinder's case, it was bubble wrap. They bubble wrapped Pathfinder, this big tetrahedral pyramid shaped lander, in these massive inflatable things. As it was a couple of seconds from landing, they puffed out, absorbed that last bit of shock, and then collapsed and got wound back in to the rover, the lander. Safely on the surface, lander opened out, and we got our very first view of Pathfinder Sojourner on the surface of Mars. By the way, if you're looking at this and wondering why the image looks a bit blurry, that is because it's a 3D image. It's designed to be viewed with blue and red glasses. But it was the very first picture that was taken of Sojourner. It's safely there. Look, you can still see the airbags still all half inflated around it. But you'll notice there are two golden canisters, one up before it and one ahead of it. And these were ramps that unfurled to let it go down onto the surface. It's also, I should say, it's very shrunk down at the minute. That is because it was kind of folded up to fit into that space for launch. Because rovers are big and gangly things, and when you're trying to launch something into space, you want them to be as small and compact as possible, so it was all folded up. But it unfolded itself, the ramps kind of came down, and Sojourner went down onto the surface of Mars. And here she is at the bottom of the ramp. Now, Pathfinder worked on the surface of Mars for 82 sols, which is 82 Martian days. One Martian day is 24 hours and 37 minutes, which is apparently very annoying when you're trying to do a mission and you're on Earth, which is in 24 hours. That kind of mismatch gets very awkward when you're doing the schedule. But this is where it was. And this is the area that Sojourner explored. And all of those places that you can see where there's various arrows, those are the various rocks and formations that Sojourner went up to, looked at it with its APXS. They've all got very nerdy names, things like Yogi and Zaphod and Indiana Jones, because NASA's full of fellow nerds who like to give everything pop culture names. And what this showed is that all of those various different rocks are all completely different. They didn't all come from the same place. They seem to have all been brought from elsewhere. And the most likely explanation for that was that they were brought in by a flood. And so that was beginning to suggest that maybe Mars wasn't, well, it wasn't beginning to suggest, it was further evidence that maybe Mars wasn't always as dry as it is now. Maybe there was a period when it had massive rivers and lakes all over the place. And what it also showed was that rovers still had a lot of work to do at Mars. And so NASA were starting to think Mars had become really like the charismatic Sojourner rover, and seeing people, the Pathfinder on TV, really got people enamored with Mars again. It was also broadcast on the internet. It was one of the most popular things on the internet at the time. This was 1997, bear in mind, so the internet was a fresh, new, shiny thing. And it really got Mars back in the public mind. So NASA wanted to capitalize that, and they came up with something called their decadal plan. And the idea behind this was that they were going to send a mission to Mars every 26 months, so every single launch window, when Mars and the Earth were lined up that you could send a mission to it. And they wanted to start in 2003, because in 2003, Mars and Earth would be exceptionally close together. And that meant that you could get more bang from your buck, basically, when you're sending a rocket. You could, for the same rocket, you could send something much heavier to Mars. You could send a big rover. And so that's what they planned to do. And in fact, they came up with two rovers, two identical rovers. And the idea behind that being that one rover is unlikely to fail, but it might. And that means two rovers are incredibly unlikely that they'll both fail. So by doubling the amount of rover that you have, you're dramatically increasing the chance of your success for not much more increase in money. And so they decided to send these 2 rovers. And what they came up with was called the Mars Exploration Rovers, the MER rovers. And there were 4 main goals of this mission. They were going to characterize the planet's past and present climate, examine its geology, and find out if it could have had life, not if it did have life, if it could, and prepare the way for future human exploration. Now, that last one is pretty much, can we land something big and heavy on Mars? It was a very sort of soft goal to please some of the bigwigs at NASA, rather than being a particularly active one that they did. But it was the first 3 that they were really interested. And basically the way that you investigate those 3 is by sending a robo-geologist. And what they sent or designed was this guy. This girl, I should say, because all of the NASA rovers are female. That was Donna Shirley, who was the project manager of Sojourner. That was her decision, and it's stuck ever since. But anyway, so this lady is basically, as you can see, she's a beefed up version of Sojourner. So much bigger, much taller, got a much bigger solar panel on them, because bigger solar panel means more energy, more power, which means you can run more instruments, you can go further, you can basically just do more. It's also got a much taller camera on it, so it could really look around and see what was going on and navigate its way across the surface. It also had a microscope on it. It had even more, it had the APXS on it, but it also had several other types of spectrometers, so instruments for looking at the composition of what was on the surface. And it also had a RAT, by which I mean a rock abrasion tool. So this was something that could go up to the surface, rub away at it, and just basically get that sort of top layer of crud off of a rock so that it could look at a nice pristine surface below. So these are the 2 rovers as they were being built. They became known as Spirit and Opportunity. You might have heard of them. And here they are. They're all kind of, here they are in a clean room being prepared for launch. So they're all kind of scrunched up, ready for launch. But building these rovers did not go to plan. I could do an entire talk about everything that went wrong during the construction of these 2. They had problems with their flash drives. They had one of them they had to unpack completely once it was all put together, and then be hunting around looking for the bits that they had to take off. Opportunity almost didn't get to fly because the cork peeled off of the outside of its rocket, because rockets are apparently covered in cork, which was news to me when I discovered that. And massive problems, but they did eventually launch. And in the summer of 2003, both of these began their journey on time to Mars, ready to take advantage of that nice close launch window. And they actually, in the end, reached Mars without much problem. And in fact, here they are on the surface. This is, in fact, Spirit on the surface of Mars. Now, they were designed to last for 90 sols, 90 Martian days. That was what was called the sort of red line first #1 requirement that would class the mission as a success. However, engineers don't like to just meet the minimum. They want to do better. And so they put on these big solar panels and hoped you might get a year out of them, maybe. But there was something that they couldn't avoid, and that was the dust. So if you look in this picture here, you can quite clearly see that the solar panels are very, very dirty. And this was something that they saw in Sojourner, is as time went on, the solar panels' productivity went down and down and down as it got covered more and more in this fine dust that's just constantly blowing up from Mars's atmosphere and from the ground. And eventually that would become so thick that the solar panels weren't generating enough power for the rovers to clear. But then in December of the first year they were on Mars, something very interesting and unexpected happened. One day, the power production on Spirit suddenly jumped up by about 5%. And when they took another picture and had a look at their solar panels, they realized that something had cleaned them off. And no, this wasn't, you know, some alien going along with a little brush. It'd be very nice if it was, but no, what it was the wind or some kind of event had happened. They're still not 100% sure exactly what does this, had cleared off the solar panels. A few months later, Opportunity had the exact same thing. And this happens to it happened to the rovers every couple of months. They just get cleared off and they could carry on going. So suddenly this mission that they thought at most would last a year had an indefinite runtime. And in fact, Spirit and Opportunity had a really good run on Mars. Spirit was the first to go. Its last communication was on the 22nd of March, 2010, sorry. And it was in a place called the Gusev crater. So this was a very mountainous place that geologists think used to be the bottom of an ocean. There's lots of evidence of hydrothermal activity. So where salt water interacting with hydrothermal vents, like on Earth, in fact, the places where we think life might have originated on Earth. So you can understand why people were interested in seeing that sort of area. Unfortunately, in 2009, it got stuck in a sand pit, which meant that it then couldn't get to a nice warm area to hibernate through the winter, and it didn't make it through, and its last communication was on the 22nd of March, 2010. Now, Opportunity, meanwhile, that had a bit of a longer run. That went for 14 years. It managed to travel 45 kilometers, so it beat out Lunar Cod 2 to take that record. And it explored an area called Meridiani Planum. And this, as you can see from this picture here, was unlike any other area of Mars we'd ever seen before. Everywhere else had been littered with rocks and debris and rubble, but Meridiani Planum had these huge sand dunes, creating these stunning images. And eventually, in 2018, as you might remember a couple of years ago, there was a global dust storm that came in. And so after 14 years on the surface, Opportunity hunkered down to try and weather out this storm. And there was a tweet that got sent out of basically anthropomorphizing its last thoughts, of which is, "It is getting dark and I am very tired," as its battery ran down from getting covered in the dust. And unfortunately, it never woke up from that. This was the path that it took right across Mars, highlighted in green. And as you can see, it's gone to all different kinds of places. It went across plains, it went to craters, and really investigated this area. It would be impossible for me because I'm already running over, to go into what these two rovers accomplished in their combined 20 years on Mars. But the main thing that they taught us was, one, how to do long-haul missions on the surface of Mars, both from a purely like logistic point of view of, you know, operating when we're on 24 hours and they're on 24 hours and 37 minutes. And also just, you know, planning those kinds of missions and making sure you don't get bogged down in this crater over here when there's something really interesting to go and see over there. Scientifically, though, what they really hammered home was the fact that Mars wasn't always a dry and arid planet. At some point in the past, it was wet. At some point in the past, it was covered in oceans. Whether these oceans lasted for billions of years, or whether these oceans were just flash floods, that remained to be seen. But there was definitely huge pools of water on Mars in the past. And it found that out because there was various minerals, clays, carbonates, things like that, stuff that can only form in the presence of water. But what they also found was that the water was different in different places. Where Spirit was, that water was very acidic, whereas for Opportunity, it was more neutral. So it not only showed there was water, but it showed that the water changed, maybe the climate changed over time. So either it was acidic, and if at some point the water was neutral, then that means it could have potentially hosted Earth-like life. And so suddenly this became a really encouraging sign of people who were hoping to understand the history of life and the growth of life and potential for life on Mars. But the big question was, okay, so we have water, that's one ingredient of life. What about the other ones? So the big thing is organic material. Now, organic doesn't necessarily mean biological. Organic means the building blocks of life. It wasn't made by an organism, but it could be made into an organism. And looking for organics, because they are big, complicated molecules, is quite difficult. It takes a big, beefy oven to look for those, something that you couldn't possibly have done with things like the Mars exploration rovers. What they needed was something a bit bigger, and what they came up with is curiosity. So to show you how much bigger it is, here are the 3 rovers next to each other. Down in the bottom left, we have Sojourner, being tiny and cute. Then we have the racing wingback of the Mars exploration rovers over on the left. And then we have the big daddy on the right. Here's Curiosity, absolutely massive science machine. And one of its biggest advancements in terms of scientific potential was something called the SAM, or the Sample Analysis at Mars. So this was a big oven that could bake the rock and get out all of the different chemicals that were inside of that rock and look at them with something called another spectrometer, and really get to the big, heavy organic molecules with this SAM oven. It was bigger, so it needed to have more power. So rather than having a solar panel and having to worry about all of that business with the dust, it was operated by something called an RTG, or a radiothermal generator, which is basically like you have a hot brick, and then you have something called a thermocouple, which turns its heat into electricity. That always kind of confuses me. Whenever you say like, it's a nuclear powered rover, you think it's this like incredibly advanced like reactor. No, it's a hot thing that we then use to turn into electricity. But the other problem that you have with your big nuclear powered rover is that it's a lot harder to land. The airbag technology was used to put down the Mars exploration rovers, just as it was with Sojourner. In fact, they used the exact same system, but the extra weight caused massive problems with the airbags. They tore when they first tried to test them with the weight from the MEARs, and they had to really engineer them to get them to work enough to send the MEARs. It wasn't going to be enough Curiosity. So what they did was they came up with a crazy plan of landing Curiosity on its wheels using something called the Sky Crane. And so basically what this was like a big device with thrusters and everything on it that could very carefully lower it onto, in precision, land the rover on the surface of Mars. And then it would detach and shoot off and crash over somewhere else. And as well as being able to land heavy things, it could also land them with a lot more precision. And that would be really important if you're ever planning on sending humans to the surface of Mars. You need to be able to land them very precisely. So that was one of the great things about Curiosity. That would help eventually get towards a human landing. And it would be heading towards Gale Crater, a potential site of a past ocean. So again, if you're going to try and find any chance that there might be life or evidence of life on the surface of Mars, it'd probably be somewhere like this. And in the middle of Gale Crater, there is a big mountain called Mount Sharp. And this mountain was laid down as sediments, or this is what geologists think anyway, sediments settling out of that ocean, out of that lake, and building up over time. And what that means is that as you're driving up the mountain, you're going through all of these layers. And so by driving through the mountain, you're driving through Mars's history, seeing how it's evolved and changed over time, and learning a lot about how its climate, how it's changed over those different eras. And again, Curiosity, big mission, been going on for 8 years now, 9 years now. And it's definitely showed that the history of water on Mars was complex. It's still questions about whether there's been some evidence that it might be actually that rather than there being oceans that lasted for billions of years, there was these temporary flash floods that came through. But importantly, SAM did its job. It found evidence of organics. That means those building blocks, those ingredients for life are there on Mars. It's another thing pointing that maybe Mars might have been habitable in the past. But to really answer that question, to really get to grips with whether life was ever on Mars, you need to be able to get a sample. And that is something that is finally happening today. People are finally working towards bringing back a sample from Mars. This is a mission decades in the planning and will still be decades to go on. And the idea is to have a 3-part mission. You will have Mars 2020, which has already happened, to send a rover to the surface of Mars that will go around, scoop up samples of rock, create these little caches, these little treasure troves, that a future mission, probably done by NASA and ESA, will come along and collect. And then a third mission will pick up that from the surface and bring it back to Earth. So this is still a multi-stage plan, still very much ongoing. But the first stage, Perseverance, happily made it to the surface of Mars back on the 18th of February. And again, this is, as you can see, it's quite similar to Curiosity. It, in fact, has all of the same instruments on it as Curiosity, plus all of the extra stuff. There's a lot's happened in the 8 years since Curiosity got built, and they managed to pack in a lot of those rovers onto the rover. And so it's going to be a general all-purpose geologist, as well as bringing back those samples to the surface of Mars. And it landed back on the 18th of February. Again, used that sky crane system, very precision landing. Actually, they thought to put a camera on the sky crane this time, so you could actually see it coming in towards the surface of Mars, which was very cool. But Perseverance didn't travel to Mars alone. Oh, in fact, here I have a picture. Is it going to play? No, it's not. Okay. There's a very cool video of Perseverance coming into landing. If you haven't seen it already, I highly suggest you look it up. But it also came with something called the Ingenuity Mars Helicopter Scout. And this is a really cool mission. It's basically an idea of, rather than taking these big, heavy, expensive rovers, what you might be able to do is send these small, lightweight helicopters that can go and explore and jump across huge areas, can go to places that rovers can't go, and do a lot of interesting things. And Ingenuity had its first flight. It's in fact had 12 flights now. It's been hugely successful. Here is a picture of it in the air, and in fact taking a little picture of Perseverance over there as well. So they've been hugely successful. But what it's really shown is that it's part of this kind of new dawn of moving away from these very big, heavy, but expensive single missions towards smaller rovers, something more like Sojourner, maybe a bit more specialized, that can go around the surface. Oh, and then there's another picture of Ingenuity in flight. So here are the Chinese rovers. So these small rovers, and there's more people getting involved with these small rovers as well. So because they're cheaper, they're much more accessible. So emerging spacefaring nations can begin to use them, such as China, which is doing some great work over on the moon. Here we have the U2 rover back on the surface of the moon again after 50 years. it landed on the surface. And the Chinese have sent 2 rovers. They sent U2 to the moon as near side, and then U2-2, which was the first thing to ever land on the lunar far side, which is very exciting. Unfortunately, problems with the U2 rover meant that because it became immobile after a couple of days, meant that they sacrificed some of the geological equipment on U2-2 to just make sure that it would keep moving. So it was the first time that we've gone to the lunar far side and it didn't have half the instruments that like all of the geologists would have wanted it to have, and there was a lot of like heads pulling hair out from the international geology community about that. But hopefully they've proved that you can land on the lunar far side, so hopefully a lot of other people will be following there soon. They also landed on Mars back on the 14th of May this year with their Zhurong rover. And here it is. So this is actually a picture of it on Mars. It took a little camera that it left so that it could take this lovely picture of itself. And that's the landing platform on the right and the Zhurong rover in the middle. As you can see, they've cribbed a little bit from NASA's notes, but you know, NASA taught us people how to build a good rover, and that was one of the things they wanted to do. Other people have come up with similar rovers. This is from India's ISRO. Attempted to land in 2019. Unfortunately, that mission failed just as it was coming into land, and they will be reattempting in early 2022. But it's not just space agencies that are getting involved. There was a couple of years ago something called the Google Lunar X Prize, which challenged private companies to land on the surface of the moon. And none of these missions were successful in the time frame. None of them won the prize. But it did what it wanted to do and kickstarted this kind of idea of maybe we can build small, cheapish rovers that can go onto the surface of the moon privately. And there's actually a mission being planned to launch 7 rovers, some of which came from this Google Lunar X Prize, onto the surface of the moon at some point this year. Their timelines have got a bit messed up because, well, the world. I don't need to explain why, but hopefully that will be coming soon. And it's part of also, you'll notice that of those rovers, most of them don't look like the standard NASA clones. You know, you've got the one from Spacebit there, which looks like some kind of weird robot spider. And then the one on the bottom from Carnegie Mellon, which is, from Pula Space, which is a Hungarian company, I believe, that's going to use legs to walk over. And it's people, as well as the Ingenuity Scout, people are beginning to reevaluate. It's like, well, maybe there's a better way to explore. NASA's just done what NASA's always done because that's what they know how to do. And in fact, NASA themselves are looking at other ways to explore the surface. These are some particularly interesting ideas. We have the Dragonfly, which is being planned to explore the surface of Titan. So Saturn's moon Titan, that was landed on by Huygens back in 1997, is going to be re-explored with, no, not 1997, whenever it happened. They're going to go back with the Dragonfly probe. And then on the right, there's various other things that are going to hopefully explore these various icy moons around Jupiter and Saturn. Because whilst Mars was once wet, it's now very dry, it's now very dead. But these icy moons around Europa, around Jupiter and Saturn, they have oceans, or at least we're pretty sure they do, under the ice. If there is life currently in the solar system somewhere other than Earth, it's most likely going to be on one of those icy moons. And so that's where a lot of these mobile rovers are going to head towards next. We're going to be seeing an increasing number of missions to these places in that kind of hunt for life, which I think is very interesting. And I am very glad that we are currently at the the edge of this. You know, this is an area of space science that's constantly evolving. You might be able to tell from my confusion at the Perseverance things about what slides I have in there. Like every time I give this talk, that's changed. You know, this is a constantly moving set of goalposts. So I'm very happy to be here and reporting on this at the moment. And I'm intrigued to see where it goes next. And as you might have guessed, I quite like my robots. And so if any of this was of interest to you, or you want to learn more about things like the static landers or impactors, then I've written all about them in my book, Robots in Space, The Secret Lives of Our Planetary Explorers. And so if you would like a copy, if you'd like a signed copy, then please do let me know. But that's enough of my plug. Thank you very much for having me tonight. And are there any questions? Now I will stop sharing my screen.